Welcome to my channel. This is Kusuma studying in Sri Venkateswara College of Engineering, Bangalore. Today I am here to explain you the topic based on chi-square distribution. Let us move on to the contents. What is chi-square distribution? Chi-square test statistics, the shape of the chi-square distributions, properties of the chi-square distributions, example applications of the chi-square distributions, and the non-central chi-square distribution. So what is chi-square distribution? A chi-square distribution is a continuous probability distribution that is used in many hypothesis tests. The shape of a chi-square distribution is determined by the parameter k. The graph below shows examples of the chi-square distributions with different values of the k. Chi-square test statistics, that is formula. Chi-square test or hypothesis test with test statistics that follow a chi-square distribution under the null hypothesis. Pearson's chi-square test was the first chi-square test to be discovered and is the most widely used. So this is the formula for chi-square distribution. Chi-square is equals to summation of O minus E whole square by E, where chi-square is equals to the test statistics. O stands for observed frequencies and E stands for expected frequencies. The shape of the chi-square distributions. We can see how the shape of the chi-square distribution changes as the degrees of the freedom, that is k, increases by looking at graphs of the chi-square probability density function. A probability density function is a function that describes a continuous probability distribution. When k is 1 or 2, the chi-square distribution is a curve shaped like a backwards G. The curve starts out high and then drops off, meaning that there is a high probability that chi-square is close to 0. So this is the graph when k is equals to 1. When k is greater than 2, the chi-square distribution is hump-shaped. The curve starts out low, increases and then decreases again. There is a low probability that chi-square is very close to or very far from 0. The most probable value of the chi-square is chi-square minus 2. When k is only a bit greater than 2, the distribution is much longer on the right side of its peak than its left, that is strongly right skewed. As k increases, the distribution looks more and more similar to a normal distribution. In fact, when k is 90 or greater, a normal distribution is a good approximation of a chi-square distribution. This is the graph when k is equals to 90. Now let us move on to the properties of the chi-square distributions. Chi-square distributions start at the 0 and continue to infinity. The chi-square distribution starts at 0 because it describes the sum of the squared random variables and a squared number can't be negative. The mean mu of the chi-square distribution is its degrees of the freedom k. Because the chi-square distribution is right skewed, the mean is greater than the median and mode. The variance of the chi-square distribution is 2k. Chi-square is non-negative is the ratio of the two non-negative values, therefore must be non-negative itself. The chi-square is non-symmetric. There are many different chi-square distributions, one for each is the degrees of the freedom. The degrees of the freedom when working with a single population variance is n square minus 1. Example applications of the chi-square distributions. The chi-square distribution makes an appearance in many statistical tests and theories. The following are a few of the most common applications of the chi-square distribution. Pearson's chi-square test. One of the most common applications of the chi-square distributions is Pearson's chi-square test. Pearson's chi-square test or statistical test for a categorical data. They are used to determine whether your data are significantly different from what you expected. There are two types of the Pearson's chi-square test: chi-square goodness of the fit test, chi-square test of independence. Example, Pearson's chi-square test. A company that sells shirts wants to know if all their shirt colors are equally popular. So, they record the number of the sales per shirt color for 1 week, number of the sales per shirt color, color and frequencies. Red 30, grey 29, yellow 26, pink 33, black 56, white 90 and blue 86. Since there were 350 shirts sales in total, 50 sales per color would be exactly equal. It's obvious that there weren't exactly 50 sales per color. However, this is just a 1 week sample, so we should expect the numbers to be little unequal just due to chance. Does the sample give enough evidence to conclude that the frequency of the shirt sales truly differs between the shirt colors? A chi-square goodness of the fit test can test whether the observed frequencies are significantly different from equal frequencies by comparing Pearson's chi-square test statistic to the appropriate chi-square distribution. The company can calculate the probability these short sale values are more or extreme values happening due to the chances. The non-central the non-central chi-square distribution is a more general version of the chi-square distributions. It's used in some types of the power analysis. The non-central chi-square distribution has an extra parameter called lambda or the non-central parameter. This parameter changes the shape of the distribution, shifting the peak to the right and increasing the variance as lambda increases. The non-central chi-square distribution. The lambda parameter works by defining the mean of the normal distributions that underlie the chi-square distribution. For example, you can produce a non-central chi-square distribution with lambda is equals to 2 and k is equals to 3 by squaring and summing the values sampled from their normal distributions, each with a mean of the 2 and a variance of 1. So guys, if you like this video, please do like, share and subscribe to my YouTube channel. Thank you for watching.